Okay, welcome to Be a Better Techie. Now today we'll get to know some information about the XML and the annotations and what are the differences. Okay, once that is fine, then we will get to know some details about the annotation retention policy in core Java and how these policies are supporting the Spring framework annotations. Okay. Then I will move it to the informative. Suppose we are having XMLs. Okay, first we will go to the advantages and disadvantages of XML. Then we'll navigate to the annotations advantages and disadvantages. Okay, in case of XML, these XMLs are too much informative, means easily human can understand. Why too much informative means each tag has their own self-explanatory. So by seeing the XML configuration, a new person or a new guy, then they can able to understand easily. And the other advantage is all configuration info place one place. This is one more advantage. If we are having all configuration information in particular place, then we can easily refer and how the things are configured, what are the things we configured, how many classes involved in that configurations. We can get to know by seeing the single XML at a particular instance of time. And if our application is very big and the complicated, then if we are using the XMLs, then the complications already the project is complicated. Again, for understanding, this will be easy if we are going with the XML configurations. Okay, and the XML tags are self-explanatory tags. We no need to spend much time on the tags, attributes and their values. These are the some advantages. There may be many, but at this point we will go with the limited information. That is fine. Then we are having disadvantages as well with the XML. So to overcome these disadvantages, annotations are introduced. Again, there are some disadvantages with the annotations as well. So at the end, it's a developer or the architect choice to choose whether go for the XML or annotations. Okay, coming to the disadvantages of XML, there are no compilers present. Suppose if I go with the Java, right, I am having Java compiler. If any syntactical error, then compiler will warn us so that we can modify. But in case of XML, we don't have any special compilers for compile the XML documents, and we need to do well-formness and validation as well. If that is not well-formness and validation is not there, then we may not get the desired output. Okay, the XMLs are not developer friendly, means non-native languages. Suppose if we are Java developer or .NET developer, they are excel in their technology. So if we are using XMLs, then they have to know something about this XML. So it's a non-native to the developer perspective. Now all these XMLs are case sensitive XMLs, so we need to take care while keeping any tags in the XML. And one more disadvantage is if any errors or any syntactical errors or semantics errors are there, then XML won't show the issue where it is. So what, as a developer, we need to do trial and error. We need to do that wherever the error, then we need to modify it. Again, we need to compile the project and deploy it. Then we need to verify it. Like that, it will take multiple iterations to fix or to make the XML documents in a proper valid format. These are some of the advantages and disadvantages of XML. Then we'll navigate to the annotations. Coming to annotations advantages, these are programmer friendly. So if I am Java developer, Java will provide the specific annotations. If .NET, it will provide the specific annotations in the .NET. So if we are going with annotations, right, then these annotations are compiled with along with the source code. So we will get the compilation support. So if any annotation is wrong, then easily compiler will warn, so we can modify the respective annotation. And if few projects, if we need to provide for quick and rapid development, then we go for the annotations based development. These are the some advantages. There may be multiple as well. And coming to the disadvantages, as updated earlier, if my project is very big and it is having multiple modules, the code is scattered across multiple modules and the interdependency between the modules is very high. In that cases, means very big applications, annotations will be difficult to understand, difficult to manage, and the newbies, whoever the new joiners or new onboarded persons, difficult to understand. Maybe if spent some time, then they can able to understand, but it's some limitation. Okay. And if the team is scattered across global, around the global, then difficult to manage, because few people may did modification at code level annotations, maybe other geographical location people may not aware. So like that, because of that coordination issue, sometimes annotations may not be the good choice. Okay, these are the few things. But again, both XMLs and annotations having their own advantages and disadvantages. Based on our project implementation and structure and instructions, we can choose anything. Okay, these are the few things about XML and annotations. Now coming to the retention. Okay, before navigating into Spring specific annotations, just we'll spend some time on the how these annotations are placed in core Java thing. Okay, what is happening, there are some cases these annotations will be applied. Suppose at a runtime there are some annotations will be applied, but at the compile time annotations may not present. How these annotations means, we'll look into. Anyway, we may get the definition from multiple sources like this. Just I opened the Chrome and I opened 2-3 links. Fine, we will get sufficient information from all the sites thanks to these articles. Yeah, coming to the annotations, there are some annotations. Okay, some annotations are used to annotate other annotations. Those annotations treat as a meta annotations. Okay, suppose if you go to Spring, right, Spring we are having multiple annotations like @required, auto-wire, qualifier. These are annotations, but there are some annotations, those will be placed on top of these annotations. Okay, those annotations we treat as a meta annotations. So @retention is one type of meta annotation. So what is this meaning and all, we'll see in a meanwhile. We have the clear-cut definition and all. These are the few articles. Yeah, now coming to @retention is also meta annotation that comes with some retention policies. These retention policies determine at which point an annotation is discarded. The meaning of retention is just to keep or hold. We are having three types of retention policies, that is source policy and class and runtime. Okay, this source retention policy are levels. Okay, these are, we can treat as a level as well. Retention policy, retention levels. Java defines 3 such policies. Fine, right? Now source is retained only in source file and discarded during compilation. As we are aware, Java has some stages, right? Like we are writing our code. That code we treated as a source, and when we compile it, it will generate the dot classes. And when we run the program, then JVM having a runtime environment. So these retention policies, if we go with the source level, then this will discard during compilation. It won't available at the compilation time. The examples we can say like author. If you go for the plain Java, right, there we are having in our IDEs we will get who is the author of the class and date, who modified these things. Those treated as source level annotations. So if my annotation is represented like source, then that annotation is present only at source level. It won't present at the class level. Okay, class is stored in the .class file. During compilation, it is not available through JVM runtime. So when I represent the class as a retention policy, then that annotation present only at compile time. It won't available at the JVM during runtime. And when I mentioned annotation as a runtime, is stored in the .class file and is available through JVM during runtime. So when I am representing annotation as a runtime, then that time that annotation is present at compile time as well as JVM during runtime. We will go this with a simple example. This is fine. We'll go to this example and we'll see. Okay, I created one similar same example. Okay, here I am having 3 classes ABC. Before navigating to that class level, let me open the annotations. These are user defined annotations. First I will open the source annotation. If you see, this is the annotation source retention. Like how we are having @required, @qualifier, @auto_wire, right? Similarly, source retention is one type of annotation. So I created the annotation here with the help of @interface, and as I updated previously, @retention is a meta annotation. So this will represent this will be placed on top of some annotations. So @source annotation I placed, and here I mentioned as source. Retention policy I placed as source. This is one annotation I created, and I created 2 more annotations for class and the runtime. Sorry, what this class retention means, this is simple annotation. Of course I don't have any body, just I given the annotation and I given @retention policy as class level. Similarly, I created one more annotations runtime. Here just I given some default string, and @retention I given as runtime. So like that I created 3 annotations with 3 retention policies. Now let me use these annotations in the individual classes. Okay, so I created 3 classes here, A, B, C classes, and for A class I given annotation like @retention, source retention. This is nothing but user defined annotation in this case, like how we are having in Spring, right? Different annotations. Similarly, this is user defined annotation, and this annotation retention policy is at source level we given. Similarly, I am having B class with the at the rate class as retention and C class runtime as retention. So I created three annotations and I applied three annotations for three classes, and I created one test demo class. Okay, this is Java. Here just we are taking the annotation information. I am creating the object dot get class, then get annotations. Whatever annotations we given at class A, that annotations I am storing in annotations array. Similarly, I created the B class object and dot get class dot get annotations. It will give B class annotation information. Similarly, C class as well, I got the information. Now here what I am doing, I am just printing these sizes of annotations. This is source level, class level and runtime level. Just I am printing their lengths. That's it. And in case of C as well. But as this code is running, right, at the time of runtime, only the runtime annotation only available. Because of that reason, when we output this one, only C specific things only we are printing. I'll show the output and then I'll show the generated classes as well. Okay. Yeah. If you see number of annotations attached, class A. Class A, you remember, right? It's a source level. Source level annotations are there, but at runtime it is not available. So it is 0. And this is compile time. Means class dot class level. But runtime, that information is not available. And this is the class C. At runtime, the annotation is available. And annotation attached to runtime annotation. Just we are printing this information, runtime information. Just we are printing this. So based on this retention policies, what is happening in case of Spring, right? If we are going with the source level or compile level annotations, then we may lose the future of Pojo. So always Spring suggests we need to create the beans in such a way that those will be Pojo classes only. So to retain that policy, means that Pojo policy, so Spring most of the annotations, I think almost, we can treat this as at a runtime. At compile time, these annotations may not applicable. Only during the runtime only these annotations will be applied. Okay, so we won't get any issue like at the developer environment things are working, and at the runtime production environment few functionalities may not work, kind of issues we may not face here. Okay, now this is the result. Now I'll show how these things are present at the backend. Okay, so here I showed the output, but when I compile this one like plain JDK itself, then what we are seeing, we got the dot class files, right? So I'll show the dot class files one time. Yeah, so I'm having class A Java file and dot class file. Means I went through command line and I generated this project Java C. Then all the compilation classes will be generated. Class A specific A class, and B.java B.class, C.java C.class. These classes are generated. Now our intention is, let's open these files and see in the dot class file whether those annotations present or not. Okay, I think I already opened the jar files. Let me open by using DJ compiler. I already opened it. Okay, here I opened by using JD compiler jar files, and I given as some extension Java. This jar file is nothing but a.class file, and b-jar.java is nothing but dot class file of b.class. Okay, let me open three files and I'll show how these annotations are appearing at the compile time as well. Yeah, as if you remember the a class, right? A class is nothing but we applied the retention policy as source. So if you see here, this is class A, we didn't see any annotation, but here if you see class A, right, this is source level, but dot class file we did not see because that is retained only at the source level. Remaining other levels like class dot class files under runtime, it won't available. And let me go to the B. If you see B, right, class retention, I applied for class B dot class level retention. So in the dot class file we can able to see these annotations like a.c means at the rate author kind of things comes under source level retention, and B is nothing but this is class level dot class level retention. So we are seeing at the compiled class dot class file and it is not available at runtime. So only we are getting here for B output as 0. Runtime it is not available. And let me open another class C. Yeah, this is class C. So as class C, the retention is at the runtime. So this will be available at the other two levels like dot class files and source level. Okay. Hope this will give some idea. With this information, we can navigate to the Spring specific annotations. Okay. Thank you. Thanks to these articles. If anything added, you can add at the description part. Thank you. I'm closing it.